Hello everyone, welcome back to my class. So today we are going to continue our discussion, which is going to be calculation of empirical formula. Okay, so last time, if I'm not mistaken, you are already familiar with the difference between empirical formula and the molecular formula, isn't it? But in here, we are going to try to practice how to calculate the empirical formula of any kind of substance or compound. Okay, so in here, let's say the first example, I have P and I have O, phosphor and oxygen. And then in this compound, the percentage of phosphor, it is 44%. For oxygen, it is going to be 56%. And then the question is, what is the empirical formula? Okay, so here you have the percentage of each of the element in this compound, and one thing that you need to know is the molecular formula, the MR of P and O. What is the molecular mass of the phosphor? If I'm not mistaken, it is going to be around 31 gram per mole. For the oxygen, it is going to be 16 gram per mole. Okay, so how can we calculate it? So here you know about the percentage, and in here you know about the molar mass. So now it's easy. So first, find for P. So basically, you can calculate the number of P using the percentage over the molecular mass over 31. It is going to be equal something. You can calculate it by your calculator. And then for the oxygen, it is going to be 56 over 16. Did you calculate this one? Well, I actually calculate this one, and it is around 1.4, and this one around 3.5. Can we use this number? Have you ever seen, let's say, P 1.4 and then O 3.5? Is it possible? Of course not. You need to have this number as the whole number, because this is a decimal number, you cannot use it. Okay, so how then? So in here, divide it with the smallest number between them. So 3.5 and 1.4. Which one is the smallest? 1.4 exactly. So here, for P, it is 1.4 over 1.4, and then for O, the same, 3.5, but divide it with also 1.4. Okay. So what is it going to be? 1.4 divided by 1.4, it is going to be 1. But O, 3.5 over 1.4, what is it going to be? It is going to be 2.5. Can we use this number? Still, we cannot, because this, even though this is a whole number, but this one is a decimal number. So how can I make it as a whole number? So basically, just multiply both of them with 2. So you, in here, 1 times 2. In here, 2.5 times 2. So it is going to be 2, and it is going to be 5. Now, can we use this number? Yes, of course. So here, by looking at this number, so 2 belongs to P, so it is going to be P2, and this 5 is going to be for oxygen. So here is the empiric formula for this substance. Okay, so we have P2O5. Okay, so I hope everything is clear. And now, let me give you another example. Okay, so here I have, let's say, SeNO. Example number 2. Se or silicon and O, oxygen. So the percentage of Se, it is going to be 47%, and then oxygen it is going to be 53%. And the molecular formula for silicon, it is going to be, I'll write it down in here, Mr of Se, it is 28.0 gram per mole. And then for oxygen, it is going to be 16.0 gram per mole. Okay, now please try to pause the video right now. Okay, try to solve these questions. So Se, it has 47%, and then oxygen, it has 53%, and then the molecular mass of silicon, it is 28 gram per mole, and then the oxygen is going to be 16 gram per mole. Okay, so now please stop the video right now so that you can try to calculate the empirical formula of this compound. Okay, and when you are able to, when you finish work on it, okay, you will find that the empirical formula of this compound, it is going to be SeO2. Okay, so please compare what you did with this. Okay, so if it is not the same about what you have done with this answer, okay, so there will be some mistake. So it means you did something wrong. Okay, but it's okay. Try again and then try to find the same result as what I got for you. Okay, so that's it from me. Thank you for your attention. Okay, and have a good day.